Okay, so here's a video about the normal curve, and this is going to follow along with what you learned about when you watch that against all odds video. Um, so this is so this is the paper you got in class, or you have to print it or copy it down if you're remote. So the first off deals with the general. This is about the 68, 95, 99.7 rule, and this is this general rule of thumb that works for normal distributions, and it's pretty cool that that happens. So you see these percentages here. So let me connect this. So the 68 comes from theory says, and it's amazing how well this works out, that 68% of a distribution that's normal in shape will fall within 2 standard deviations of the mean. So 1 standard deviation below, 1 standard deviation above. And notice that I split the 68 in half for 34% and 34%. And because this is a symmetric distribution, I can do that. So if I want to know what numbers there are, so they're telling me, what are they telling me? They're telling me the mean, the middle is 23.8 miles per gallon. Then they're telling me the standard deviation is 7.2. So in notation, the parameter is, and we learned about that last week with sampling, that the mean mileage for these cars, whatever year it is, was 23.8. And then the standard deviation for this distribution is 7.2 miles per gallon. So if we add a standard deviation to that, so let's see, so we're going to add 7.2 to 23.8. That's going to be 10. I'm going to carry the 1, so that's going to, it makes 11, right? Carry the 1, so 33.01. We can also subtract it the other way. What's that? 6. So I'm 1 standard deviation below the mean. And what is that? 16? Yeah. Now, I'm not doing this to make you subtract decimals. What I really want you to be able to do is to do this with a calculator. Here, let me go get a calculator that'll work well with the screen. And I mean, your phones will do this. Google Calculator will do this. I've just got this fancy graphing calculator. So what I'm going to do is I'm going to take 16.6 and subtract another standard deviation. And that gives me this next cutoff, which is 9.4 miles to the gallon. And I'm just, because while I'm at it, I'm going to take away another 7.2 and 2.2. Man, that must be a 8-cylinder car that is not tuned up very well. So you see how 68% of the distribution will fall in there. So this tells us that 68% of the cars will have gas mileages between 16.6 and 31.0. This is definitely old data. There's no way cars are getting 16.6 miles per gallon again, unless it's a real old V8. So now to get the middle 95%, I'm going to just add another standard deviation. I probably don't need a calculator for that, but I could. I mean, it could just go 31.0 plus 7.2, but I think I can do that in my head, make it 38.2. And then I can add another 7.2, which is what, 45.4? Maybe I better double check my arithmetic with that. 38.2 plus 7.2. Yeah, 45.4. Not bad. I'm glad I can do arithmetic. So this says 99.7% of the distribution, practically all. So it's going to be very unlikely to get a car based on if this is true, to get a car that has more than 45.4 miles per gallon. Obviously, this must have changed now with Priuses and electric cars, right? And I'm certainly not going to get a car that's less than 2.2 miles per gallon. So then once I've got this well-labeled sketch, all we got to do is what's the middle 95%? Well, I know that 2 standard deviations away from the mean, below it and above it, will capture 95% of that distribution. Do you see that? 95%. So it'll get between cars between 9.4 miles per gallon and 38.2 miles per gallon. And then what percent of automobiles get between 31.82 and, oh, I could answer this one. What percent of cars or autos get more than 31 miles per gallon? So here's what you got to think about with this one. I know that that's 2 standard deviations above, or 1 standard deviation above the mean. I know that there's 68% right there. Well, then I've got an additional 13.5 and 2.5 and 0.15%. Well, if you add those up, this basically, I know it might not exactly, and then of course that goes to all the way to the end. That's going to be an additional 16%. You could add up those numbers and get all that. So 68 plus 16 is 84% of the cars will get less than, oh, should get less than that. So that tells me 16% will get more. I should read these questions a little more carefully. So that tells me there's 16% up here too, because together, this is 68%. I mean, right here, that's 68%. That means, let me approach this a different way. I know if the middle 68% is there, I know the whole curve is 100%, the whole distribution is 100%. What's 100% minus 68%? Well, that's going to be 32%. And half of that, because it's symmetric on either side, is 16%. Okay, so I don't have to add up those, but I could. It'd be a little off, I think, because of rounding here, but close enough. This is actually the easier way to do it. So I know that 68% fall above that. About what percent of automobiles should get between 31 and 38.2? Well, right there, see that? Between the 1 and 2 standard deviation mark? Well, right there we can say about 13.5%. Then they want me to describe the mileage for the top 2.5% of cars. Well, 2.5%, is this where I went astray? I bet. So the top 2.5%, well, let's talk about it besides my numbers. If I know there's 2.5% here, I know this is symmetric, so there's going to be 2.5% here. That means if I add those, don't I get 5%? So that's 95% in the middle. So what number cuts off that middle 95%? Well, that's 2 standard deviations, because this is 1 standard deviation away, 2 standard deviations away, 3 standard deviations away from the mean. So here's the 2 standard deviation mark. So the top, to describe the gas mileage of the top 2.5% of cars, they get better than 38.2 miles per gallon. So you see how I use that number, that cutoff, to describe that? So that's using the 68, 95, 99.7 rule. And then what happens, and these are nice numbers to use, and these are approximations, they're a great rule of thumb. Just so you know, you're a genius if you score 4 standard deviations above the mean. That's how they use that. And you qualify, and you're also, I believe you qualify as a gifted child in high school if you score more than 1 standard deviation above the mean, or maybe it's more than 2 standard deviations above the mean. I'm not quite sure what that is. And you qualify for special education services if on, it's a ratio of what you know versus what you should know for your age. And if you score the more than 1 standard deviation below the mean, that's what qualifies you for special ed services. Okay, it's not that you're slow or anything. It's just that you're what you know versus what you're able to show on a test. Maybe I should rephrase that. And of course, I don't honestly know. I know that I've been told that at one point in time. So see that, so that's how where this comes in. SATs use these normal curves. You get a percentile when you take the SAT and or the PSAT, you get a percentile back. And we're gonna find out for more numbers, because not everybody scores one standard deviation above or one standard deviation below a mean, or for example. So there's got to be other ways to do that. And here's the beautiful way to do it. So a livestock company reports the mean weight for a group of steers. What's a steer? I hope you know that's a beef. That's a male beef animal that they raise to butcher for meat. That's what a steer is. And actually, they castrate the animal so it grows faster. But that's too much information for this problem. But that's what it is in the livestock company, factory farming. So they tell me they on average, these young steers have that for an average weight, and that's the standard deviation. So we know that mu, the population mean for this group of steers, is 1123, and we know the standard deviation is 77. And we could run out, no, here's some old, I didn't think to edit that. We aren't no longer going to do this because we've got another tool we can use, and since you all have access to computers, we don't need to use a graphing calculator. So we're gonna find the answer. Well, let's draw a little picture of this, just like before, and we could make it very complete like we did with the 68, 95, 99.7 rule, but we don't have to. Well, maybe I will for this one. So that's the mean that goes in the middle because it's a standard, it's a symmetric distribution, right? Means in the middle, medians in the middle. Then I'm going to add 77 here. You know what I'm going to do? I'm going to draw 3 lines above, 3 lines below, 1, 2, 3. And then I'm going to get my handy dandy calculator going. I'm going to say 11 here. Let me clear that out. 1123 plus 77. So the next cutoff is 1200. The next cutoff is 1277. I probably could have done that in my head. And 1354. And then to go below it, I'm going to go 1123 minus the standard deviation. Whoops, 1120 here. 1123 minus 77. So that's 1046, 969, and 892. Now remember, this is plus 1 standard deviation. This is plus 2 standard deviations, plus 3 standard deviations. This is minus 1 standard deviation. This is minus 2 standard deviations. This is minus 3 standard deviations. Okay, now they're asking me what percentage of steers weigh more than 1,300 pounds? Well, 1,300 isn't one of these nice, neat numbers. It's in between those two. It's going to be pretty small, right? Because if we know if that's 68%, that's 95%. We know that that's going to be less than 2.5%, but let's get an exact value. So here's one way to do it. Now, we did z-scores earlier this year. And remember, a z-score is you're going to take the mean, take the value minus the mean divided by the standard deviation. And this will tell me how many standard deviations above the mean it is. And we know it's more than 2, right? So let's do it. So the z-score here is actually, you know what, let me come up here and let me add in. So what are the 1,300 pounds? I want to find the area. So there's 1,300 pounds, and I want to find that probability, that area. Okay. So let's find that z-score. So I've got what, 1,300 pounds minus the mean of 1123 divided by the standard deviation of 77. So that's going to be, oh, I should be able to do that in my head, but it's Sunday morning and I don't really want to think right now. I actually need a little more coffee. So I'm getting 177 divided by 77. That tells me I'm 2.2 0.99. That's my z-score. So I'm 2.99 standard deviation. See, I rounded. And now we got to figure out what's that area. What's that area underneath it? And I don't have the nice normal curve, the 68, 95, 99.7 rule to use. So I've got to find another way of finding that area. And there's another way. Let me come up and I'm going to show you this David Lane applet. I better grab this and come back. And I have this linked in Canvas for you. Right here in week 13, you want to click on that David Lane normal calculator. And of course, I got it so it opens in a new window. And that takes you here. Notice they don't have 1123 in the middle. They have 0. Well, why is that? Well, let me come back to the sketch. What we just did is we found the standard normal curve, okay? And what that is, the mean, see if we take the mean and we take the mean minus the mean, that's 0. That'll have a z-score of 0. And then we have 1 standard deviation above, 1 standard deviation below. We have 2 standard deviations above, 2 standard deviations below, minus 3 plus 3. So then we could find what's that probability of following 2.299 standard deviations above the mean. It corresponds to this. It's just we made it standardized. Okay, we are never going to do this. I just wanted you to see that how it's something you already know and why that applet has 0. Okay, but let's go get an answer this way. Actually, here's what I can do since I'm right here. What you're going to do on that David Lane applet, you're going to leave the mean as 0 because that's the middle. It's the standard normal curve. The standard deviation's 1, and then we want to go above 2.299. Now I'm going to go back to the applet and show you how to do this with that. Okay. Let's see here. So I'm going to go above, and all I got to do is type in 2.299, and then it'll automatically see that answer right there. So just over a 1% chance of getting a steer that weighs more than 1,300 pounds at the start, if the average is actually 1123. Okay. So that's that, and that's that easy. You just have to write that down. Let's see, what did I say? 0.0108. 0.0108. So 0.0108 or a 1.08% chance of getting a steer that weighs that much, if that's the true mean. Okay, now if we do it without z-scores, and that's where you're going to do this, you're going to do some changing. You're going to change this to 1123 because that's the actual mean. You're going to change the standard deviation to 77 because that's what it actually is. And then we want to go above 1,300 pounds because that's what they asked us. More, see how they asked us what percentage of steers weigh more than 1,300 pounds? So that's how we fill it out. Now let's go fill this out and we'll see what the applet tells us. I gotta get these pop-ups stopping. Chrome is going crazy with pop-ups. So I'm gonna change this to 1123. I'm gonna change this to 77. And I wanna go above 1,300. So now I'm no longer on that standard normal curve. You see I'm getting the same answer though? And notice how this table, see how this fills it in really nice, and it even gives us a little shaded area. So this David Lane applet is wonderful for the normal curve. Okay, so that's that answer, the same answer, and that's all we got to do to fill it out. So let's come here. Let's see. Is it here? Since maybe I don't have to go back to the Elmo. Maybe I can just start doing this here. Let's come down to another one. What percentage of steers weigh under 1150? Well, maybe I should come back with a sketch, because I want to show you that you don't have to do such a detailed sketch. Especially when the applet will do it for us. So I know, here's what I want to see. Just make a little sketch, put the 1123 mean in the middle. Now 1150, here, let me get a different color ink. 1150 is about here. It doesn't have to be exact, but they're saying under that. So I want this area to the left. Okay, so all we've got to do is now go back to our applet, and we're going to change this again. This is already 1150, or 1123, sorry. 1123, this is already 77. All we're going to do is we're going to go to below 1150, and that will give us that shade, and it'll also tell us the probability. So let me come back to the applet. And we've already got the 1177. All we got to do is change it to below 1150. And look at that. Look what it draws us. And there's the probability. So what's that? About 63.71%. 63.71%. Remember, you got to multiply by 100. So 63.71% of the steers will weigh less than 1150. Okay. What percent of steers will weigh between 900 and 950 pounds? So a little rough sketch is the mean in the middle, 1123. Then we've got 900, and we've got 950. And we're looking for that area there. Let's go back to that original normal curve here. 9 to 950, you see how that's all down here? So this is going to be a pretty small percentage, isn't it? Because that's out more than 2 standard deviations away from the mean. So we know there's going to be a pretty small answer. Okay, so let's go back to the applet. And I want to know, I want to change it to between, and you can just type in the 900. And whoops, make sure it's not negative. Do you see that? 900 and 950. And lo and behold, look, it gives us that, and it gives us a pretty small. So isn't that interesting? 0.01, so about 1.04%, right? Okay, so I'm not going to write that. I'm not going to go back to because you can copy that down and make that a percentage, right? Well, maybe I should. Maybe I should come back here. I don't know who's seeing what. So that worked out. Remember, in the table on the applet, it told us 0.0104, and I had to move the decimal point over 2 places, times that by 100, right? Now, the next thing is a little different, and I hope you notice this. To save money, the livestock company wants to cull the lowest. That means get rid of them, right? The lowest 20% of steers, because they're not growing fast enough. So what weight should they use as a cutoff? So I know the mean, if the mean's true, and they want me to cut off the bottom 20%. So this area here is 0.2. I want to find out what X cuts off that bottom 0.2. Now I can't do this to do this longhand old school, I'd have to do a Z-score, look up in a table. The beautiful thing about this David Lane applet is it does it for us, and let me show you how it does it. You guys are fortunate to be learning statistics now in this day and age rather than, say, 10 years ago. So you see what you got to change here is I want to know a value from an area. Basically, a percentage or a probability is an area because it's an area under the curve. And the area we're looking for is 20%, so 0.2. And then we got to change in the mean, 1123, and the standard deviation, 77. That doesn't go away. And we want to know below because we want the bottom 20%. So they're saying cull any animal that weighs less than 1,058. I mean, we would round down. We would still round down to 1,058. So you see that? So they'd have to go out to their feedlot and put those animals through a scale. So what's it, 1,058? So that's going to be the cutoff. Sounds kind of bloodthirsty, doesn't it? Okay, so that's how you do the inverse normal. And I guess we'll do some more. I got another example here. Okay, let's see what happens here. If you've had enough and you know what you're going ready to you can do, you can go ahead and just keep rolling with it. I guess if we're gonna do a well-labeled sketch, let's do the full thing. Now you can certainly, now that you know how to use that David Lane applet, you could certainly cheat with this and just let it fill it in for you. I'll refresh your memory here since you haven't listened to me on this video. 3 lines above, 3 lines below. Remember 68, 95, 99.7. The mean's 8.4. So the mean mu equals 8.4. And the standard deviation is 1.7. And so I'm going to add here. Where's my calculator? Sometimes you can get a calculator, whether it's Google or your phone. If you type in the mean, then you go minus, and we're going to mine off minus 1.7, and you can just keep hitting enter the 3 times. It'll take the last answer and subtract 1.7 for you. So let's see. So it makes it a little easier. 5 and 3.3, and then I'll do the same thing. I'll do 8.4 plus 1.7. 1 standard deviation, 2 standard deviations, 3 standard deviations, 10.1, 11.8, 13.5. So there's my well-labeled sketch. Now, one thing I am noticing about this is you see how these numbers are exactly what my normal curve, the 68, 95, 99.7 numbers are. So I don't have to use David Lane. You can, it wouldn't be wrong to. If on the exercise set that I'm going to have you do, if they say use the 68, 95, 99.7 rule, or the empirical rule is another name for this, you have to do it this way. If you try to use the applet, it'll mark you wrong, okay? So it never hurts to make a good sketch. So what percentage falls in that range? Well, if we go back to that very front page, I see that that's 1 standard deviation above, 1 standard deviation below. And you see when it's 1 standard deviation above, 1 standard deviation below, that's 68%. So the answer is 68%. Less than 3. Now 3 is off the scale, isn't it? So that is going to be a David Lane problem. 11.8. Now 11.8 is not. That is a David Lane number. And I see that that's 2 standard deviations above. So that'll give me 2.5. So 2.5%. What is the 2.5th percentile? The bottom 2.5. Well, remember, if you go 2 standard deviations below, that covers the 2.5%. You see, less than 2.5 right there, less than that. So it's going to be that number there, which is 5. What is the unit here? 5 minutes. And what value is the 84th? Well, remember when we did this one here, we got 84%, and that was 1 standard deviation above the mean. So 1 standard deviation above the mean is 10.1. Okay. Now I guess maybe what I should do before I end this video is let's go use the David Lane applet for this one, since that's not 3.3. I wonder if I didn't have a typo on my part. And then let's see how we can use that inverse normal to get these answers. Okay, let me go start up that, go back to that applet. Here we go. So I want to know an area from a value. I need to know the mean is 8.4. I know the standard deviation is 1.7. And I want to know below 3, right? So below 3 minutes. And that will be a pretty small area. Practically, really, that's practically 0, isn't it? So I would write down 0.0007 minutes. Or no, this is a minute. This is the probability. So we could say 0.07. You could say practically 0 also, because that's a pretty small number. So that would be B. Let's look at D and E again. So the 2, do I have that right here on this paper? Here we go. So that should be the practically 0 number. Now we're going to look at this. I mean, I knew that by counting on my sketch. I knew how to do that. But how can I do that with that applet too? So what we're going to do is come back to the David Lane applet. And I have everything set up, but I want the value from an area. And actually now it's not set up. I forgot I had to do this. So the mean is 8.4. Whoops, that's the area. 0.025, 2.5%. The mean is 8.4. What here am I? 8.4 and 8.4, Dan. And the standard deviation is 1.7, right? And I want to know below, there's the bottom 2.5%. So what did I say? 5 minutes on my sketch. Well, and the applet's saying 5.1 minutes. See, it's a little bit different. Here it's not rounding. We were. Now the bottom 84%, we're going to come back here. So this would be E. I do 0.84. It'll automatically update. I said 10.1, and that would be 10.1. So if this was my open math, I wouldn't be getting it wrong. Okay, so that's that video. What do you got to do now? You're going to come back into Canvas, and you're going to go try this normal curve work. This is the My Open Math assignment. If you want, I can stream. I guess I can start up a Zoom. I'm going to do this in front of the room like I did with the last one for everybody. I guess what I can do during class is I'll fire up a Zoom section so you can see the screen and hear the discussions. I think I can get my mic to work so you can hear it. Okay, so hopefully that'll help you get this all done.